topics that we are going to discuss in today's session. It's like India's main sources of renewable energy. Why we need renewable energy? Why the renewable energy is like why everyone is talking about renewable energy? Then we will discussing about the scope of solar energy in India. Then we will discussing about like what are the government initiatives has been taken to promote solar energy in India, right? Then we will be discussing about the initiatives that has been taken by our university towards promoting solar power generation. Okay. Then we will be discussing like a very basic overview of the microgrids. What are microgrids? And then last 2 points, it's application one and application two. Here, I just want to discuss with you like the few projects that we did, just to mention how one can make use of renewable energy for specific applications and how we can make use of renewable energy for energy generation, right? So yeah, that's we already discussed, right? It's a quick recap just to summarize. What is the renewable energy resources? As okay, so it's quick recap just to summarize. Like what is renewable energy resources? And you all guys mentioned that what is the renewable energy? It's like energy which can be renewed with passage of time, right? Now when it compares to non-renewable. And the next question is that what are some example of renewable energy resources? And it's like solar, hydro, wind, and biomass. Everything is like these are all the components of renewable energy. Okay. And another question, last question is that according to you, what do you think? What are the types of renewable energy resources that we are using in India? So it's like we are using solar, wind, hydro, and at the same time biomass also geothermal. Okay, so let's move further. Yeah, this is the okay. Yeah. So basically, no sir, I will be just using the board also. That's another. Okay. So this is like the map which depicts what how much every source of renewable energy contributes for power generation in India. So it's 34% solar, 13% thermal energy, that is geothermal, not the thermal energy that comes from coal. Okay, 6% small hydro, and the 47% that is wind power, right? So here today we will be focusing more on solar energy because the answer is pretty simple. It's because like look, wind power is like as you can see it has major contribution towards renewable energy generation, but wind is limited to like a specific geographical location, that is India has a very good coastline. Okay, so wind is like okay, it's like limited to that much area only. Okay, wind we can't make it widespread all over the nation. So solar is the energy which we can exploit more. Okay, so like as per the data, as I will going to explain, depict it in the earlier next presentations. There is a data where there has been survey has been conducted, and that survey mentioned that India receives like around 300 to 300 days of sunlight every year, right? 300 days of sunlight. So this shows that solar has a good scope of future, as a good scope in the future. In the future, when it comes to power generation from renewable energy, okay, that's why today our main focus is on energy generation using solar. So yeah, as I mentioned, these are the scopes of solar energy. The first point, like India is, we have like a very good advantage, a geographical advantage. As you can see, this article was published, and that article mentioned that India received approximately 250 to 300 days of clear sunny days. This shows that we have a good scope of solar energy in India, right? And at the same time, the report stated by the Central Electricity Authority, they are also working towards like to increase and its renewable energy generation from 18 to 40%, 44%. So here solar will play definitely a major role. As you can see, this is the India solar energy potential, and in all the states, it's like it's in good amount. Like as you can see, like in Rajasthan, Madhya Pradesh, Uttar Pradesh, Gujarat, And in Maharashtra, Andhra Pradesh, everywhere there is a good scope for a solar energy generation using solar. Okay. And at the same time, this is another figure fact that we have include. It's like India in total receive like 5,000 trillion kilowatt hour of solar energy each year. And we have a huge potential that is 748 gigawatt of energy generation using solar. So you see that solar has that much capability that it can play a major role in the upcoming future when it comes to energy generation using solar power, right? That is why today our main focus is mainly towards solar energy only. So yeah, as I mentioned, these are few of the government initiatives that has been taken to promote solar energy in India. The first one is the PM Kusum Yojana. I think most of you were present in yesterday's lecture by Bhagwan Das, so they were free with it. Here, that project also is a part of this scheme only, okay? PM Kusum Yojana. So what this scheme is doing is that it's like promoting solar for agriculture level. Like what government is doing is that government is providing funds and subsidies to the farmer so that they can establish solar grids at their farms, which can be helpful for them like for domestic purpose also and for agriculture purpose also, like right, you have solar plant, you will generate electricity that you can use to run pumps. Now you are not dependent on the main supply, electricity supply. This will provide an independent energy generation for the agriculture sector. And there was a major, like we all know that in 2012 there was a major blackout. You all remember what happened, like for the they wanted to create a havoc. Everything got stopped. Why? Because we were depending on the electricity supply, which was coming from the main grid. Let's suppose if we have solar and let's suppose the main grid is down, we can use solar for energy generation. We are energy independent. There is no need to depend on other because there is no need to depend on energy generation from fossil fuels. And another example why solar is important or why renewable is important, you know that right now there is a war going on between Russia and UK, or in Russia between Russia and Ukraine. Sorry, and you know like what did Russia did? They cut down the supply of UK, right? The gas supply. Now they are in cripples. The economy is in cripple. Why? Because major energy generation in UK comes from gas, which they purchase from Russia. So this depicts that okay, right now India is an energy independent country. We produce energy and we have surplus amount of energy. But you see that most of the energy come from fossil fuels, and that we import, like petrol, we import from other countries. So where is the surety that in near future, if something happens, those countries will put some sanction or they can do anything, right? Because they have the control over those resources. So we need energy independence in terms of generation also and in terms of resources also, right? So that is why we have to exploit, or not exploit, we have to search or do research in this area more and more so that how we can make use of solar as a major sector of energy power generation in India. So these are few schemes. Another scheme is like Jawaharlal Nehru National Solar Mission, which promotes installation of rooftop solars in households, right? So this is another scheme both the schemes are launched by Ministry of New and Renewable Energy. So these are some of the government initiatives that has been taken care of when it comes to promote solar power generation in India. Okay, yeah. And yeah, these are few initiatives that has been taken by our college, right? One example you saw like yesterday, there was a 20 kilowatt power plant in Delhi, right? That was completely a solar plant, and all the basically the machinery or everything that we were using here, it was solar powered. And at the same time, we see that our main faculty, the engineering faculty, or all the complete campus of Dayal it runs on solar. Right now, the building in which we are sitting, this is also solar powered. So this shows that our college is working like in a serious way or in a sincere way when it comes to adopting solar power, and it provides it sets a benchmark that yes, we can rely on solar power generation when it comes to when it comes for energy generation, we can rely on solar, right? So yeah, these are some of the initiatives that has been taken by institute, and these are all the government funded projects. Okay, so yeah. So there is one question. According to you, what do you think? Okay. So there is one question to you all. According to you, where is the largest solar power plant is generated in the world? Can you name me the country? In which country it is located? I'm asking about country, not state. I'm asking about the country where the largest solar power plant is located. Any guesses? Yeah, it's India only. It's in Bhadla region in Rajasthan. That is the world's largest solar power plant. It generates power around 2245 megawatt of electricity. It generates. It's in India only. Right now, from the top five, top one and top three are from India only, the solar power plant. And rest two, I think, is from China. So yeah, we are currently leading when it comes to energy generation using solar. That's a good point, right? That's a good example that yeah, in India there is a good scope for solar. Okay. So yeah, what is solar energy? What do you think? What is solar energy? It's just a basic depiction. Like suppose there is a photovoltaic cell. The sun radiation are coming. It's getting striped here, and then there is a movement of electrons. There's a flow of electrons, basically photoelectric effect, and then there is a power generation. It's taking place. Okay, and basically photovoltaic cells are like they are just made of silicons, and they are it's like doped in such a manner like when we incident light on that or sunlight, the electrons are generated, right? So basically this is how solar energy is generated. Yeah, so if but as you see it's so easy, right? Just sun, there is a cell, sunlight is there, that's it, power is generated. So why we are not able to adopt or we are not able to completely move towards solar? The reason is simple, because there are many limitations. One such limitation is that the panels are not cheap, they are very expensive because of the metals, that is cadmium and indium, which are very rare metals. We use them for their for the production. And yeah, another there is an example that I have depicted, like an average Indian house requires 3 kilowatt of power, right? Means like a single panel has a power rating of 345 watt. Okay, and we require a power of 3 kilowatt average house. So how many panels do we need? We need 10 panels, right? 0.45 kilowatt, but that's okay. We are close to the figure. Okay. So, as per the market survey, the panels that is like there's the panel from Adani Powers. It mainly costs 1,700 rupees. So for 10 panels, how much will be the cost? 79,000. You see, the cost only to purchase panels for a 3 kilowatt is some 79,000. So the cost is one such factor which plays like which basically create a hindrance when it comes to adopt solar power generation, right? But yeah, government is providing subsidies, but still it's not too costly for the middle class Indian to afford solar, right? Another factor, now it's technical factor, like that is a fill factor which leads to decrease in efficiency of the solar. Now what is fill factor? I will explain you. It's pretty easy. So basically, like this is, we will draw a curve, okay? So this is a current, this axis depicts current, and this axis depicts voltage, okay? So basically for a solar cell, for a photovoltaic cell, the curve is like this. When you will see the data sheet provided by the manufacturer, you will see this, okay? The curve is like this. And the power output curve with respect to voltage, it's like this. You can see, okay? Okay, no. See, it's like this, okay? It's somewhat like so. You see, like when you see, this is the actual value that we will theoretically we will get, but practically we are getting only this much amount of power. When you plot these value on the axis, it will be like this. Okay, so like this one the figure that you have seen, it's like the actual power, that is the theoretical power that we should get, but this much is the only power that we are getting from the system. So that's why this is known as fill factor, right? Basically, you see that our panel is intended to give this much power, but we are only receiving this much amount of power. So this is one problem with solar. The situation, that is the phenomenon that is called fill factor. Okay, so it's pretty important. Like, and One more example, like the company, the JSW, in the interview, they also ask one question. Basically, what is the fill factor? So this phenomena is called fill factor, right? What is the fill factor? It's like our panel is intended to give this much amount of power, like the complete power, but we are only able to receive this much amount of power because due to some losses, internal losses. So this is phenomena is called fill factor. So these all phenomena lead to the limitations of adopting solar, right? That's it. Moving further, and yeah, this is like a curve for the solar. This is it's respect to power and the output voltage. I will explain this curve, don't worry. But just for now, it's like a curve which depicting like this is the power output curve for the solar cell, a single solar panel. Okay, so this is like this point, as you see, here is the power maximum, and rest all the cases it's minimum. It's minimum compared to this case, right? So this is like a curve. We will move on to we will look into this curve later also because it's very important, the analysis of this curve. Okay. Okay, sir. एक्चुअली मेरे को सर बोर्ड चाहिए सर।
अगर वो चाहिए तो इसकी टच स्क्रीन पर आप वो कर सकते हो।
ओके बट सर ठीक है सर, कोई प्रॉब्लम नहीं है उसमें।
प्रॉब्लम नहीं है, रिकॉर्डिंग कुछ चीजें को में तो नहीं होगा।
Sir, I will come here. And when there is some things right, then I will.
टाइप और यहाँ पे आके आना है यहाँ।
Okay. Okay. So what? Yeah, we were discussing about the limitation of solar, right? And this will be I show like what is the problem with the solar? There is a condition of phenomenon that is slip factor, right? So we discussed that thing. Okay. So moving further, like as how many of you are there from the domain of electrical engineering? You are from electrical engineering domain. Have you studied the subject called power electronics so far? Power electronics, have you studied? Control systems? You study control systems, right? Power electronics you will study, don't worry. So we are now I just want to discuss with you like what is the scope for all these subjects that is which we study, like power electronics and control systems, when it comes to energy generation using solar, right? What is the usage or what is the use of this theoretical knowledge that we gain from this subject and how we can implement it in practical level, right? So you see, this is the block diagram that we have. I just have put here. It's like, look, there's a panel, there's a charge controller. I will explain basically what is a charge controller. Don't worry. There is a panel, there is a charge controller, there is a DC load. Okay, and there is a AC load. Why? Because if we have to use some AC load also for that, we have put an inverter. Okay, and there is a battery. There is a battery also. Why? Because as sir mentioned, that what is the limitation with solar? It's not available like 24 hours. Like for some time it is available. So why what we are doing here is that with the help of battery, we are absorbing the excess power, or sorry, the remaining power back into the battery. That's why we are using. It's a storage system. So basically, this is a simplified block diagram of an off-grid PV system, right? What is an off-grid system and what is an on-grid system? This is another problem. This is another question. So yeah, what is the off-grid system and what is the on-grid system? Before moving into that, tell me what is the grid? Anyone? What is the grid? I think you have heard what is the grid fail, grid stability, smart grid, grid. What is the electric grid? Any idea? Basically, a grid is the interconnection of like many separate components. Like what? There is a power generation unit, the transmission unit, there is a distribution unit, there is a house, there is a load. This complete network. It's all grid. So what is the on grid? Is like there is on an on grid. We have this system also. Like we are generating energy from our side also, but we are also using the electricity from the grid also when our system is not able to do that. Like sir mentioned, like in our college only, like in the daytime we are generating electricity from solar, but at night time we are taking power from the torrent. So what is that? It is an example of on-grid system. Like there is both. Like there is main electricity utility, main electricity also supplies also there, and we have our supply also, right? And what is the off-grid? In off-grid, we have only like there is a single source that is we are generating electricity from our own. We are not using any electricity or we are not purchasing any electricity from the main electrical grid. Okay, that is an off-grid system, which is away from off-grid. Off-grid means the system which is in which there is no interconnection with the main grid. Okay, that's a basic difference. So yeah, explaining that what is the scope for power electronics, right? Why I'm telling you is that because look, charge controller, inverter, what are these? These are they have circuits, and how those circuit works? Those circuits like works with switches. What are switches like? Transistors, MOSFETs, IGBTs. All are the parts of power electronics for me, right? So here comes the usage of power electronics and the control system. How we use control system, that I will explain. But how we are using these subjects for for obtaining our objective, for achieving our objective of power generation using solar. Okay, so these are the tools. Like we are using the knowledge of this subject as a tool for our purpose. Okay, so yeah, look, a solar charge controller. What is a solar charge controller, right? You see, like there is a panel, and now, as I mentioned, that this curve is very important. Look, we'll correlate all the things like that. Why we are using a charge controller? Why we are not like directly connecting the load to the PV panel? Okay. So this was a curve as I drawn like okay. The power versus the voltage curve. Okay. And you see that this is the maximum. This is the point. Which what is called? It is called MPP, maximum power point. Because why it's called maximum power point? It's evident. Like only at this point the power is maximum. If we go there, power reduced. If we go there, power reduced. Okay. What happens is that if you connect a load directly to the PV panel, what will happen? Based on the irradiance, what is irradiance? Is that the sunlight that is coming. If it decrease or increase, the power will increase. Okay. Let's suppose my MPP is at this point and there is no controller. So a plant that is capable to give power of this level, it is only giving this much power. The efficiency is decreased, right? So why we are using charge controller is that so that I can all the time I can track this point only. So to increase the efficiency of the system. Why? Because let's suppose the panel is able to generate 100 watts of energy or 100 watts of power and I am only using 50 watts. So what is the use? So that is why the role of electrical engineering comes. That is why the role of electrical engineering comes. That is how we can increase the efficiency of the system. So as I mentioned, this curve is very important. So that's why to track this maximum point all the time, we are using this charge controller. Okay. So and yeah, at the same time, if I will directly connect the battery to the panel, what is the problem? There is a panel, there is a battery directly interconnected. There will be a problem overcharging because there is no circuit there to protect that thing, right? And what is the problem with overcharging? Have you ever saw that when you charge your cell phone and you touch at the back after 100% charge, it's little warm. It's little warm. Because why? There's a chemical reaction in the batteries, okay? And imagine you overcharge your battery. What happens? Its life will degrade, right? And the battery system is very expensive. We all know that. That is why comes the role of an engineer to design this system of charge controller. Okay. So you see, this is a panel. Okay. What we are doing is that we have sensors, a voltage sensor and a current sensor. We are sensing the voltage and the current of the panel. Okay. We are giving it to the microcontroller. Any microcontroller we have. What that microcontroller is doing, it is generating a duty signal. And you were in the first presentation, you have the sir explained us about the role of buck converter. So basically, I will explain what is duty. Don't worry. So this is the buck converter. Basically, this converter is like that. So yeah, with the help of microcontroller, we are generating a duty cycle which is used to basically for the switching of buck converter. Okay. So I will explain it. Don't worry how it is working. Do you know what is a buck converter is? Yeah, DC to DC means what's the buck converter? Step up, no, step down. That is boost. Boost means it will boost. Buck means it will cut down. Okay. So basically, what is a buck converter is that it's a DC-DC converter which basically lower down the DC voltage or cut down the DC voltage. Okay. Okay. So I will draw the circuit of the buck converter. Okay. Okay. So basically, this is a buck converter. And what is this? It's a MOSFET switch, a semiconductor switch. So now, as I mentioned, duty. What is a duty? It's a pulse. It's a pulse signal. Okay. Let's suppose this is a square pulse. Total time T. Time period. The time up to which the pulse is high, that is called T on. And this is called T off. Okay. So what is the duty value? It's D equals to, yeah, what is? T on upon T. T on upon T. Okay. This is the value of duty. basically, um, what the microcontroller is doing is that microcontroller is giving this much signal, and what if I will increase the duty or I will decrease the duty, the switching of this MOSFET will change, and that will provide me a voltage level as per my requirement. Okay, so that is why we are using a charge controller, so that we can regulate the voltage at the output of the system of our photovoltaic system. Okay. So yeah, that is the role of a charge controller. Okay. So let me also explain you a very that we will do in the next presentation, in the next upcoming presentation. Okay. So yeah. So this is a solar charge controller. Any questions? No. You have any questions, anyone? So yeah, what is a solar charge controller? Just normally tell me, what do you think as on the presentation we have? What is solar charge control? Speak and we don't mind. It's okay. No problem.
So panel would be different. Battery voltage is the voltage I control
Okay, yeah.
over charging, yeah, voltage.
What he's trying to say is that he's right. He's not able to explain clearly. As we know that at the photovolt at the panel, the output is very fluctuating. That's what he explained. So that is why we're using a controller to regulate the output. Okay. This is done with the help of a charge controller. It's a basically control circuit for the converter, a solar charge controller. Okay. So you have to keep this in mind. What is a charge controller? Yeah. Now there are different types of charge controller. A PWM based charge controller, a fuzzy logic based charge controller, and an MPPT based charge controller. Okay. Hey, today we will be focusing more about the MPPT charge controller, not this PWM fuzzy. And mostly we also prefer this system, this MPPT controller only. Why? Because it has a good efficiency compared to PWM. And fuzzy is very difficult or not difficult, it's complicated to install, or it's complicated to design fuzzy controller. That's why today we will focus on MPPT charge controller. Okay. And another reason why we are choosing MPPT controller is because I showed you the graph in the very beginning, that power versus voltage graph. So I wanted to tell you that how that graph is important, because that graph has an important role when it comes to design a solar system, photovoltaic system. Okay. That is why today we are focused on MPPT charge controller. MPPT means maximum power point tracking. Okay, maximum power point tracking, because solar curve is not straight, it's not like it's a parabolic. At a specific point, the power is maximum. Okay, that is why we need a charge controller which can track that point all the time. So that is why we are using MPPT, that is maximum power point tracking based solar charge controller. Okay, yeah, this is a logic. Don't worry, it looks very difficult. I will decode it. It's easy. It's an algorithm. It's an easy algorithm based on the curve. Just I will explain you how we are writing this algorithm. Basically, this algorithm is for the maximum power point tracking in the solar panel. Okay. So again, come towards that curve that we draw. Okay. Power, voltage. Okay. What is this point called? Anyone? PP. Some power point, right? Okay. If the point is maximum, what will be the power? Maximum. And what will be the voltage? Again, maximum. Okay. So maximum power point voltage. PMP. Okay. What is the y-axis? Power. What is the x-axis? Voltage. What will be the value of the slope? dP upon dV. Because delta y by delta x. What is m? Mathematically, delta y upon delta x. So what will be the value of slope here? dP upon dV, right? dP upon dV. So look, we know As per mathematics, at the value of maximum, what is the value of differential? It's 0. Because at maximum, what is the value of dp by dv here? It will be 0. Right? There are three cases. Either dp by dv can be 0, dp by dv can be positive if we will move here, or dp by dv can be negative. Okay. These three equations are very important when we are designing this controller. Okay. So what we are doing is that how this algorithm is working. This graph is important. The maximum power point dp by dv is 0. Now imagine we are here. Let's say this is the point A and this is point B. Okay. This is point A. If we have to move to the maximum power point, what we have to do? We have to move here, right? We have to increase the voltage, and increase the voltage means we have to increase the duty cycle. Okay. So how? For the case of buck converter, anyone know the relation between the output and the input voltage for a buck converter? No, don't worry, it's okay. This is the equation. Output is basically D times input. V output equals to D times V input. Input means here V has been source. Okay, so this is the equation. If the voltage we have to increase, output voltage, we have to increase the value of D. Right? That is why if we are here and we have to move here, we have to increase the value of D. Right? Another case, if we are here, what we have to do to go to this point, we have to go back. We have to decrease the value of D. This is what this algorithm is. Okay. So what I am doing is that I am starting my algorithm. Just follow me, okay? Start. We measure the output voltage and the output current of the panel. We get the power from that. How much is the power? We estimated the power. We get the change in power. How much there is a change in power? Okay, we get the value of dp. And at the same time, we also get the value of dv by calculating the actual the difference in the voltage. Okay, so we get the value of dp and dv. Now we have three cases. Either dp by dv can be 0, dp by dv can be greater than 0, or dp by dv can be less than 0. Based on these conditions that we have defined, we have put it in this logic. If my dp by dv is 0, stop. System is okay, we are at the power point, stop. If dp by dv goes down, controller has to work to give maximum to generate more duty so that we can reach the maximum power point. If dp by dv goes forward at this point, now the controller has to repeat it again so that we can move to this point. So this is how this algorithm is working. It's a simple algorithm that is called perturb and observe based algorithm. Why perturb and observe? Because what controller is doing is observing what is the value of dp by dv. If on the basis of observation, what is doing? It's perturbing. It is perturbing means it is changing the value of d. It is changing the value of d again and again. That is why it's a perturb and based MPPT algorithm. Okay. And there are a few other algorithms also, but this is a very basic one and not so technical. So that just to depict you like how analyzing the things are important. So this is a very important graph when it comes to designing maximum power point algorithm. Okay. So this is how this algorithm is working. So any questions so far? Any confusion? No, right? Clear? Okay. Yeah. So till now, what we have discussed is like what is a solar photovoltaic system. Like from the school, we all have listened or learned that we can generate power from solar. Like, power from solar is easy. Solar energy can be used for power generation. But now you realize that how it can be generated. Okay, what is the role of an engineer? It's not like that I will take a panel and I will connect it power generated. No, you have to design a sophisticated system for that. That here comes all of an electrical engineer, because you have to design controller, we have to design a complete system. That is why it's expensive also, right? To design a charge controller, to design a sophisticated algorithm, to design a microcontroller, to design everything, it's expensive. That is why there is a problem. That is why we are not able to focus towards solar. Why? Because it's quite expensive. Okay. So far what we have discussed is that what is the basic, how does a basic solar photovoltaic system looks like? A solar photovoltaic system. Okay. So as I asked that what is a grid? Okay. Now you know what is a grid. What is a grid? It's like there's a national electrical grid of India. So what is that? What is a main grid? It's like there's a large power generation station. What is a power generation station? From that they're distributing the electricity, and there is at the distribution there is a transformer, and at the transmission end there is a transformer, distribution transformer. They're distributing electricity to the locality, to the loads. Okay, so this is the main grid. Now, what is the microgrid? What is like, as the name suggests, it means a small version of a grid, right? In like yesterday only we see there was a this was also an example of microgrid. Why? Because that system, there's a main power generation, that is there are panels that are located there. There is distribution is also there, right? We are distributing electricity. Sorry, transmission is there, and at the end there was an inverter which was distributing electricity to different loads. And there was also a storage also, right? So you see, what is a microgrid is that it's like, look, there is a main grid that we have always have, and these are all other sources that we are using. So every single source is acting as a microgrid. Suppose for any reason this grid fails, so no problem. We have other sources also to compensate that. As I give you the example, 2012 blackout. And sir also mentioned yesterday, like in that blackout, from that blackout, everyone suffered severely. But our institute, because of the installation of these microgrid, we were able to withstand that calamity. For 2 days, there was no power cut in the year, and later electricity was restored. So this shows what is an importance of microgrid is, right? Um, so this is why that's why I just wanted to give you overview, because in every presentation we have heard about microgrids, what this microgrid, smart grid, microgrid. But what is microgrid is? It is this thing. There is a main grid. These are other source of power generation. This is the storage. These are loads, and this is the control. Okay. So this is basically how a microgrid is look like. What is a difference between a microgrid and a grid? This is a difference. Okay. Yeah. Till now, any questions? If you have, you can ask, please. Any questions? No. Okay. So I have one question now. It's easy. It is based on the presentation which Srinath sir gave. Let's see. Do you remember what he explained or not? Okay, it's a simple question based on some observations. Imagine this symbol is what? Okay, there is a current I1 here. Here is also I2. Here it's I3. All are same. Then there is a current I here. Okay. I want you to ask what is the relation, or not the relation. There will be some wire to transmit their current. There will also be a wire here. Okay. Tell me which wire will have a greater area and why. Yeah. Which one? Which wire will have a greater area? I current. Why? Yes, you are right, because I will be equals to, okay, I1 plus I2 plus I3 means I will be equals to 3 times this. That is the internal current, okay? So what is V equals to IR? If I is larger, R will be lower. And if R is lower, means area will be rho L upon A, larger. That is why, okay? That's it. That is why the reason is that why here we use a low Gauss wire and why here we use a high Gauss wire. Because this is a high current capacity compared to this. And there is also economic factor. If I will use here a wire of this much capacity, it's of no use. It will only cost more. It will only cost me extra money. So that is why I just wanted to ask you this question. Okay. Okay. Yeah. Now coming to the few of the projects that I did, which shows that what are the applications of photovoltaic systems, how we can make the photovoltaic system of the renewable energy sources for our applications. Like this one example is like how a photovoltaic system can design a bidirectional EV charger. Don't worry. I think you are confused what is a bidirectional EV charger is, but it's okay. I will explain. And there is another example where there is an energy management system for a PV-based microgrid. Okay. So first of all, let's come into this example, this application. Okay. So everyone knows what is EV, right? Tell me what is a basic difference between an EV and an IC engine vehicle. How? What is the main difference between what is the main component of an IC engine vehicle? And for V, what is it? Or for EV, what is the main component? Motor drivetrain, right? So in EV is basically what is it? It's a type of vehicle that is running on electric power. Okay, instead of an IC engine, we are using a drivetrain. That is motors, BMS, and everything, all the components. Okay, yeah. So in India, tell me one more question. Tell me three names of electric vehicles that are currently existing in the Indian market. Four-wheeler. Okay. Tell me the Toyota which car? Nexon. Okay, one is Tata Nexon. Okay. Punch. No, I'm asking four-wheeler. Remove Ola. Okay, sir. Ola will also consider. In four-wheeler segment, it's the most popular EV. MG is there, right? There's some Mahindra also. So yeah, in India right now there is a transition in the automobile sector from conventional IC engine vehicle to electric vehicles. But there is one problem. As you see in Agra only, there are like you will go from Waterworks to Bhagwan Talkies, you will see 4 petrol pumps. You see any charging station? No. So what is the problem? The problem is of charging infrastructure in our country right now. We are adopting EV, no problem. But the pace at which we are adopting the charging infrastructure, that is very slow. So this is one challenge we can say that we have to overcome as an electrical engineer, how we can overcome that challenge. Why? So there are few problems that we basically first looked into it, what are the problems right now and how we have to solve those problems. First problem we all know. A country that is that is developing, its development is directly linked with energy. As far we will develop, industry will increase, everything will increase, the power generation will increase, we need power generation. So energy is generating at is growing at exponential rate, and right now we are depending on fossils that will become obsolete in the near future. So we need some other things to so that we can switch from renewables, from fossil fuels towards another sort of power generation. So that is one problem. The next problem, yeah, as I mentioned, the current energy demands are heavily reliant on fossil fuels. Okay, we all know that in India right now, major generation from coal. Coal is not fossil fuels, it is not good for nature. So there is another problem. Yeah, another problem is like wind and solar. How it's a problem? Because yeah, solar and wind are available, but there is another problem is that wind is not available. Wind is not available at every place. It's available in some specific part of the country. Similar with solar, it is not complete. It is not completely available for 24 hours. For some specific amount of time or amount of time, initially it is available. This is another problem. And yeah, because why are the factors? The factors are because of geographical factors, right? Because in north part of the country, solar is available at a very high amount of solar is available compared to the hilly areas. This is another factor. And yeah, as I mentioned, limitation in charging infrastructure. There is no charging infrastructure. So if there is no charging station, will you buy the electric vehicle? No, because now you will say that yeah, it's not a problem. I can put a charger at my home, but that charger charge your car very slow. And suppose you need a charging at instant. So what you will do? There is no charging station, right? So this is the main problem. That is why we are not currently moving towards electric vehicle 100%. Okay. So in this problem, with the help of this solution, with this application, we just have depicted how we can overcome all these problems. Okay. Yeah, solution. We have talked about problems, now we will talk about solutions. So yeah, as we know, let's suppose solution number one. What solution number? So how this solution? What I'm going to discuss is that the application that we provide, how it can be act as a solution for the problem that we have discussed. Okay. So this number one. Let us suppose that there is a grid that is fully reliable on renewable energy. And as we all know that renewable energy is not a completely reliable source. Suppose that for the complete week there is no sunlight. It's completely raining. What will happen if the system is fully dependent on solar? Everything is gone. There will be a power shortage. So the system that we've designed, it can help with this thing, with this problem. Okay, the EVs. Okay, one more thing is that what is the main problem in adopting solar is that we all know, or we have already discussed, what the major expensive component in solar energy is the battery, right? Battery is very expensive when it comes to adopt solar energy. What is it? What is an EV? EV also has battery, right? Can we make use of EV as a battery storage? Because look, most of you are four-wheelers, right? Is it used daily? A week you use it for a day or two. Okay. So the rest of the days EVs is not used. It's only like it's remaining idle. It's of no use. And we all know that if we don't use a battery for a long amount of time, it will get degraded. So that is why the solution that we have proposed, we can make use of EV as an energy storage system also. Like when the EV is not in use, we can use EV as a backup source because it also has a battery, so it can act as a backup source, right? So this is how we can solve the problem because at the same time, EVs are expensive, right? So if EVs can be used as a power source, the energy storage. So what we will do is that suppose there is excess power generation, we will send the excess remaining power again back to the grid. We will sell it to the electric utility, and what will happen? The user will get some money also, right? So it's like an advantageous situation if we will adopt this sort of terminology. Okay. Yeah. So moving forward, before starting this topic, I want to ask you one question. Till now, it is clear, like what we are going to discuss. Okay, so what was the problem? What was the problem was that? What is the problem with the EVs? Like EVs are okay. It's a new technology and it's clean in nature, but the problem is that of charging infrastructure, right? So the solution that we are proposing is that it can solve that problem. How? We realize that EV can also be used as an energy storage system. So as a battery, it can act as an energy storage system and it can provide some revenue to the user also, right? So that is how I am depicting you that how we can make use of renewable energy for applications, various applications. This application is of charging for electric vehicles. Okay, so a bidirectional converter topology. Now comes the term bidirectional. Okay, don't focus here. Focus. Look here. What is the bidirectional converter? Don't worry. You know buck, you know boost. There is a buck converter, there is a boost converter. This bidirectional converter, it's a combination of both. That's it. Okay. So I will draw the figure here. Okay. This is a bidirectional converter. How it's a combination of buck and boost? This is the source. This is the output. Okay. Now look at this circuit from this side. From this side. Okay. If this is connected and this is open, how? It's what? How is it? And what is a buck converter? This is how a buck converter looks like. Okay. This is a buck converter. If you will look of this to the circuit on this side, it is also a buck converter, right? And similarly, what is a boost converter? This is a buck converter, and this is what is a boost converter is. There is an energy storage element. This is a switch. There is diode, freewheeling diode, and there is a capacitor for filtering. It is out. Okay. Look at this circuit from this side. Source, inductor, it's a boost converter. So basically, what is this converter doing? Like, okay, so this converter is like combining both these two circuits. We are getting this thing, a buck and a boost converter, right? So this is how we are optimizing it. We don't need to use two different circuits. We can only make use of these two operations in the same single circuit. That is what is called bidirectional. Okay. If I will use the, if I will go look from this side, it is doing buck operation. If I will look from this side, it is doing boost operation. Power is flowing in both the directions. Here I will get a low voltage level, here I will get a high voltage level. Right? Power is flowing in both the directions. This is how a buck converter is working. This is basically, as we see here, it's the basic topology. Okay. There are several other topologies for the buck converter also, but we have focused to this topology because it's easy. It's easy. It's just like combine both the circuits and we get the operation. That is why. Yeah. Now comes the system specifications. Like the converter that we have designed, these are some of the specifications that we have taken. Like, look, this input, we have maintained 380 volts. This output, we have maintained 340. From here it is doing buck operation 380 to 340, and from 340 to 380 boost operation. And the EV that we have considered here, Tata Nexon example, because Tata Nexon battery has a voltage above 320 volts, and as you see, and it's a capacity of 100 Ah. It has a 100 Ah battery. So we have taken example of Tata Nexon because that is like EV that is affordable for the middle class people. That is why we have taken that example. Okay, so this is our system specifications, and these is the rated power of the system, and these are all the values of inductance and switching frequency. These are okay, and this is the main thing is like this is these two things, and these the EV battery voltage that is 320 volts and rated capacity is 100 Ah. This example is of Tata Nexon. Okay, so yeah. Now moving further, yeah, this is how our system architecture looks like. Now look, how I just wanted to tell you what is the application of solar photovoltaic systems when it for our application, right? How it is using. Like this is a solar panel, this is a charge controller, this is the bus, DC bus. These are the loads. There is another system, and there is a bidirectional charger. So in the daytime, what it is happening? The car is getting charged, the system is getting operated. Okay. And if at the night time, what will happen? This is gone, it's not here. Then this bidirectional charger, this EV will be utilized as a source. The loads will be operated. This is the basic idea of developing this. This is the basic objective behind developing this idea, right? In the daytime, it's acting like a normal charger. It is charging the vehicle. At the night time, it is utilizing the vehicle as a power source, right? and we are able to operate the loads. So this is, I just wanted to depict how we can make use of solar photovoltaic systems, and how we can make use of knowledge of power electronics and control systems, which we'll see later in our day-to-day applications. This is an example of EV charging. Yeah, this is a control strategy. It looks difficult, don't worry. How this control strategy is working. Okay. So charging mode. During what in charging, what it is happening? This is our input. This is our output. Our battery will be there. Yes, buck operation will happen. During boost, what will happen? The during discharging, what will happen? The battery has to discharge. It has to provide this to the grid. Main grid. So 340 is the voltage. It will boost it up to 380. So during boost discharging, the system is acting as a boost converter. There's a boost operation. So look, this control strategy, there is a charging strategy, this is a discharging strategy. There is a switch, and there is a comparator. What is a comparator? It's just for the comparison. Okay. So there is a reference bus voltage that we have fixed. Like if the value of the bus voltage, that is this voltage, if it's greater than this value, then we will do charging operation. And if it's less than this value, then we will the comparator will give us zero logic, and the switch will move here. It will do the discharging operation. This is the basic control strategy that we have developed. Okay. So based on the reference, we are generating a control signal, and based on that control signal, we are choosing whether we have to do the charging or we have to do the discharging. And at the end, we are getting a duty cycle. Why? Because we have semiconductor switches, and we are using this duty cycle to control this the switching of these conductors, okay, of these MOSFETs. So that's it. That is how it's a simple control strategy. All we are doing here is that we are taking the reference. There's a reference bus voltage that we have set, and we are taking the feedback of the voltage again and again, and we are seeing if that is greater than this value, then it will be 1. The measured bus voltage and the logic will be 1. If it is 1, charging I have to do. And if it is less, the logic will be 0. Discharging I have to do. That's it. It's easy. So here comes the, I will go into detail of explaining more about it in technical terms, but I just want to show you that what is the use of our theoretical knowledge of subjects that we are using. Look, this is the control system, right? It's a control system. I think you all have studied. Like there is a control system. Why? It's a summer. This is a plant. This is a transfer function. This is the output. We're taking a feedback, doing it again and again. So what is this? It's a control system. We are making use of the control system here, right? And this is power electronics. We are using MOSFETs here. We are using basically power electronic circuit, right? That's it. So this is how we are getting an idea like what is the role of an electrical engineer of developing all these things, right? Okay. So this is our control strategy for this particular. Yeah. Okay. So based on the control, based on the logic, we have defined an algorithm, like how the system will work. The algorithm, look, there is a bus voltage, there's a reference that we have fixed, and look, as I told you, like how that this is the control logic that is inside the comparator. How the comparator will give a logic 1 or 0. If the measured bus voltage is greater than B was, it's a flow diagram. If it's greater than yes, the battery will charge. If it is no, battery will discharge. And if it is equal, we have to do nothing. Leave it. So this is a normal control algorithm that we implemented. Okay. So that's it. It's easy. Yeah, these are the simulations. Okay. So look. This is first look at this figure. Look, this is a figure. It's the output voltage that we are getting from the PV. Sorry, from the PV panel here. So look, when the irradiance, the sunlight we are getting, it's 500 watt per meter square. This is the voltage level. If it's sunlight, if the irradiance is increasing, this is the reference level. If the irradiance is increasing, this is the reference level. So you see, we have fixed this as a reference, and if the voltage is beyond this, And if the voltage is beyond this, means the reference, the major voltage is greater than the reference, where charging will occur, and it's less, where discharging will occur. So based on the logic that we implemented, during the time of charging, you see the battery is getting charged. When here the battery is getting discharged. Okay, this is the SOC versus time curve. This is the SOC versus time curve. Okay. Yeah. So now one question: what is SOC? State of charge. Look, in your cell phone, you see a battery indicator 78%. This is what this is state of charge. Means out of 100%, there is still 78% charge left in the battery. So this is what this is state of charge of the battery. What is state of charge? In a simple language, it's like how much charge is available in the battery. And how is it measured? It is measured by the value ampere hour. How? Just look, I is what? Rate of change of what is current? Q by T. I equals to Q by T. Q equals to I into T. And what is I? Ampere. T is hour. So this is how we are getting the value Ah. Charge is Ah rate, state of charge of the battery. Okay. So these figures depict that the logic that we've incorporated is working. During this case, when the voltage is higher than the reference measured voltage, charging is happening, battery is getting charged. And when the measured voltage is less than the reference, battery is getting discharged. And it's the simulation, and yeah, here also. Here we make use of MATLAB. Okay. So this also depicts like all these softwares like MATLAB and all, how we can make use of the software. We didn't fabricate any hardware circuit. We did all these things on MATLAB. So this shows that why simulations are important. Because at first, there is no cost involved. You don't have to buy a physical system. At the same time, you can design like powerful circuits in your computers only. You can test them. So this shows or this depicts the role of the MATLAB. And as you see that yesterday also there was a lecture from the technical expert from the industry. Who was explaining about the role of the simulations. So this shows how powerful simulations are. Here I just use, and MATLAB is a very easy software. I just use it on my new laptop. Look, it's a Core i7 with 8 gigahertz RAM and 10 Windows 10 edition. That's it. So this whole system we have designed it on MATLAB Simulink only. So here I just wanted to show you that yeah, simulations. That's why I wrote simulation results, because we build a simulation and we test it again and again after proper changes. These are the outputs that we are getting. Okay. Okay, so mathematical validation. What it means is that the SOC at the time of charging and at the time of discharging, the value which I am getting, is it correct or not? So look, during the time of charging, this is the value. This is the curve that we get. It's a charge. This is how much the value of charging current is, around minus 70 amperes. Okay, minus 73. Yeah. So this is the equation for the SOC estimation. It's basically derived from the Coulomb counting method. That method is not 100% accurate, but here just for a simplicity you can understand it. I have just put it this formula here. Coulomb counting method. Okay. Through this equation we can get how much charge is there in the battery. This equation is for charging. Okay. I will explain this equation. Don't worry. Okay. Look on the board. Why or how we are making use of this Coulomb counting method? So SOC at any time instant will be equals to SOC at previous instant plus I into T upon battery capacity into 100%. Okay. So according to Coulomb counting in very basic terms, imagine there is a container, a water container. Imagine a battery as a water container. It's not true, but just so that you can understand it, how this algorithm is working, I'm explaining you. Battery is not like a container. There are other parameters also. There are other things also you have to consider. But just for simplicity, we are considering this case. Imagine there is a container. Yeah. Let's say it can hold up to like water at this much level, and water is available into this much level. So how much water is available in the container? 50%, right? Look, it can afford that water to this much height, h, but here the water is afford up to the height of h by 2. So how much is the quantity right now? How much is the quantity available in the container? H by 2 upon h into 100. How much? 50%. So basically, Coulomb counting also doing the same thing. Like, what is the actual SOC level of the battery at that instant? And how much charge is getting flowing into the battery again and again? We are integrating it with respect to time here. Like I into T is what? Charge. So how much charge the battery is getting at the instant of time? So this is how we are getting this formula of the Coulomb counting. Okay. So you look here. I put these equations, these values like the charging current is the 73 amperes. Initial state of charge of the battery is 45%. Nominal capacity is 100 Ah, and the time I just run similar 0.2 seconds. After putting all these values, I get this much percentage level. And if we will go back, here you see it's 45.04, right? And here also look, it's close to this value. So this shows that the system is able to follow the things correctly. The graph is depicting it. And at the same time, here you see, here what is the discharging? It's 44.94%. Okay. And here also, when it comes to discharging, look, this is the value that we are getting here. For the discharging case, the current is 100 Ah, 100 amperes. Again, everything is same. We put the values in the formula only. And this is the value that we are getting, 44.94. So this also validates our model that yeah, the model that we design is working perfectly, because now we have, based on the equations that we have derived that yes, the value which is showing in the results, mathematically also these are values are correct, right? So that's it. And moving further, yeah, this is another idea. So yeah, no wait, I will, before moving into this idea application, just a minute. Yeah. So yes, so with this idea, what we are trying to portray is that in the market, why EVs are not adopted? It's simple: high cost and charging infrastructure. So what we are solving, what we are giving as a solution in this with this application. Here we are saying that use EV as a storage. When EV is not in use it as a storage, energy storage. And so if you will use it as storage, it will generate power. If the power is remain, power is remain. If there is some remaining power, send it back to the grid. You will generate some money also. So here we are utilizing electric vehicle as an energy storage system. So that's why we are saying with this problem, with the solution, that EV can be used, how EV can be used as an energy storage system. For that, we have designed a system that is a bidirectional charging system. And through this slide, this application, you see that what is the role of an electrical engineer when it comes from the perspective of power electronics and control system. Okay, this was the first application. So based on this application, if you have any question or any doubt, you can ask. Like this is a very basic equation of Coulomb counting, but you should know it. It's not in use, because look, battery is not like a water tank. Battery has a chemical structure. There is some internal resistance inside, everything inside. But still, just for the sake of simplicity, I just want to depict you that mathematically it's correct. The formula that we are the curve that we are getting. That is why I depicted you with the help of this equation. Okay, Coulomb counting. Why Coulomb? Because charge. So we are counting how much charge is getting inside or outside again and again. That is a Coulomb counting method. Any questions so far? Okay. So this was the first application. Now we will move on. Okay. So that's it. That was like okay. My basic idea to explain you that how you can make use of renewable energy resources for application purpose, right? Energy generation is okay, but at the same time, with all these, with new technologies and with new ideas, you can solve the real life problem also, right? Because that is the role of an engineer. How you can make use of a theoretical knowledge to implement at practical level, at actual level, so that you can solve the actual problem. So that's it. Thank you very much.